Hello, and welcome to Live Coding with Gerph again. Today we are going to be having a look at what we can do about some of the other operands that are not very friendly inside the disassembler. So, if you've not been here before, this is where I go and code a little bit more of the RISC OS module I've been working on. So this is a RISC OS module being written in C, and it was originally based on a disassembler that was in GitHub that seemed reasonable, and it now has a number of commands on it, most of the same commands that we've got on the standard RISC OS Classic debugger module, and we've been working our way through implementing other features. What we've got at the moment is a reasonable module that seems to do things okay, and which has a few differences to the RISC OS Classic module. So let's have a quick see what we've actually got in it. So if I remember rightly, I left behind some files that have got disassemblies in them. Apparently I don't remember that well. So there's new debug and there's pyro debug. So pyro debug has got the debug output from RISC OS Pyromaniac, and new big debug has got our debug output. So let's just regenerate that. So new debug, there we go, builds the module, and then we load the module and we do a disassembly using my debug utility here. So this is actually the test code that I used to have on, or still have on, RISC OS Pyromaniac. So it checks what the behavior is. So here we go. Let's run this and see the output. Come on. Thank you very much. And then we can have a look at that. So that says new debug there. So that's got a whole bunch of things that are slightly different. So here we've got things like the LSL instruction, which is actually a MOV with a shift on it. So those are not in the usual form that you'd expect from RISC OS. So what we can actually do is I pull up the comparison of those two, and it's gone to the wrong screen. There we go, this is better. Whee! Right, so this is the differences between the two. It's not quite fitting on the screen, is it? And now we've got Glauer gas spinning. There we go. Right, let's move this onto the screen properly. Can you go full size, please? Good starting point, this. Right. Move it to the top. Resize it back onto the screen. There we are. All right. So here we've got some differences. And these are actually relatively simple. They're not actually that complicated. So most of these we're just moving the LSL, LSR, ASR, or ROR out to the right-hand side. Here we've got some differences about the constants that are being used, how they're represented. They're not such a big deal. I think we can cope with that as it stands. That one's quite interesting though. So that's move negated. So it actually comes out as 288. It's not a very obvious one, which is why we have this comment on RISC OS Pyromaniac to tell us that it's not. It's actually a negative number, so that's not a difficult one. What else we got here? That's another constant. This is another one that's slightly different. It's setting the flags on it. Fair enough. Comments are different. Very slightly different way of representing it. So that's an uncommon shift, and they've actually just converted it straight to a number. It's unlikely that's going to bother people. These ones, the case is slightly different. We could probably handle that. And this one, the RRX number 0, RRX never takes a parameter, so that's actually wrong, really. RRX, I think, is the same as a rotate right of 0. So I think that's actually just a thing we can tweak there. That's not too bad. This one again, capitalization, yeah, not a big deal. Capitalization, lower, higher, that's not a problem. Set endian isn't supported by the Capstone debugger. That might actually be a MISTI code, I'm not sure. We'll have to have a look at that one. Again, some shift differences, not a big deal. These ones, we've lost the P bit, which is kind of interesting. I don't think it actually has any meaning on later ones, but it is significant on the sort of code we're seeing, so we probably want to include that. And then there's all this status register stuff that's gone very wrong. Oops, went a bit far there, sorry. So these are MRS instructions that have just come out as SSML ab, wait for interrupts, yields. That's very weird. So I think that might be a fix to the core code. We might have to make some changes to that. Have a see. And then further down, there's just these slight differences here in how it's representing some of the ranges in the code. So let's start out with the ones at the very top, the LSL instructions through to the shifts basically. So we'll make those work properly. Okay, let's start out with that. Easiest way to do that is probably going to be to just convert them as they're processed. So let's see what we can do. What have we got here? So this is the function. This is where we were looking last week. This is a function that disassembles a word at an address, and we're given that we've got it as thumb or not. And we convert a number of things. We've got, is it an SVC instruction? We change it to be a SWI instruction. That's fair enough. And then we go and look it up as well. LDM, STM, we change the way that they're presented. What we got here, ADRA, LDR, and then we're fixing some of the notations. So instead of using OX, we use ampersand for hex numbers. So in order to do these, let's do some very simple checks, shall we? Oops, I've gone a bit far. It's a little bit laggy on my machine, this, so I sometimes overshoot where I'm going. All right, MNEMNIC. So L and one bracket S and mnemonic. Oop, no, that was not spelled right. Get rid of that. 2R or. So this will get LSL and LSR. Or to ASR. There's ASR, or ROL or ROR. So ROL and ROR is going to be very similar to this one. Oh, hang on. I've done LSR and LSR. That's wrong, isn't it? LSL and LSR. And this is ROL and ROR. ROR. Or the other one we need is the RRX. Was RX in the list? It was, wasn't it? Maybe not. Maybe RX isn't in the list and it's just a separate one. Maybe I should have included a test for that here. Because it's only used later on. Right, we'll skip that one for now since it's not actually in this test. We don't actually know if it's going to be a problem. Okay. Right, so shifts that appear as modern notation, RSL to MOV RSL number 3. That's what we're going to be doing. So I think right, the first thing we normally do is we copy these. So we copy the arguments to our new string because we can't necessarily edit the one that's in the buffer. So copy them to our string, and we want to find last comma. So we'll find the last comma and move backwards. So what we'll do is we'll find this comma here, and then we'll move forwards to there, and then we'll insert the 3 letters and then the number 3 at the end of it. So last comma equals structure args, comma, no, comma, not hash. There we go, find the comma. And just in case something's gone wrong, we'll only handle it if we actually find a comma, because maybe something goes wrong and it doesn't write a comma in there. Copy the string. Now, new args, bracket. So we want to terminate at that last comma. Well, just after that last comma. Actually, we also want to check whether there's a space immediately after it. So we can skip over the space as well. New args, bracket, last comma, +2. So I want to go on 2 from it. We want the index of that within the arguments array. So this should be the new array, looking at the hash symbol, and we'll terminate it there. Actually, we don't even need to terminate it, do we? We just need to put the 3 letters on it. So new args, bracket, 0. First sharp, and then that was the second, and then the third. And now that's a bit redundant, so we'll just drop off those ones. Oh, I need to add a bit more to that, don't I? So I need to add 1 to that, and add 1 to that. And then I want to copy, so struct copy from last comma +3 +2, so that's the hash symbol. No, from there, sorry, I've got this round the wrong way, haven't I? Copy it to new args, bracket, last comma. You know what, this is silly, isn't it? Why am I doing it this way? So right equals Oh, gone too far. Right. Cut. Points to the hash in the output. There we go. That's much nicer. And then all I need to do in here is to start write plus plus on each of them. Like that. That's nicer. And then we're now pointing at what should be a space. So we do copy to, oh, I didn't mean to do that. I wanted copy to write from last comma plus 2, which is the hash. And hopefully that will work. Like that. Right, I think that should fix them. So let's try running it and we'll see what comes out. So instead of writing it to a file, we'll just write it to the screen and we'll stream it out. Okay, that's a good starting point. It's broken with implicit cast of non-zero int to pointer at 124. Ooh, I missed my ampersand there. I want to get the address of that character, not the actual character. And well, that was unsuccessful. Oh, I know why. I haven't, but at this point, we haven't yet uppercased the characters. So all of these have got to be like tweaked to be lowercase, because it returns them as lowercase. So that was a little bit silly, but oh well. S-O-R-A-S-R. There we go. There's a little bit of code down here, if we just scroll down, that for the mnemonic characters, we just to upper it. And that's what's caused it to break there. Right. Oh. Well, that was disappointing. Look what I've done there. If mnemonic 0 is L and mnemonic 1 is S and mnemonic 2 is L or R, or it's an A and an S and an R, or it's an R and an O and an R, L or an R. Come on, someone, point it out to me. Anybody spot what I've made a mistake on? Ah, yes, that's what I've made the mistake on. I've manipulated the string, but then I haven't actually updated. This is the one we're going to use. So it's just using the one as before and actually reassigned it back to the new address. Okay, come on. New variable. That's still not. Oh no, that's not right. Oh, that is very confused, isn't it? Okay. I want the rightmost comma It still didn't seem to copy the string though. Am I being stupid here? It's possible I'm being stupid. Oh, yes, I am being stupid because I'm copying the arguments to here, not the mnemonic. I want to copy the LOL or whatever, not the R1. Ooh, and I think it's butted up against this because I've forgotten that we want to actually copy the space as well. So let's just put that in like that. Okay, here we go. Bum, bum, bum. They all end up lowercase. Well, that's understandable because they were lowercase before. All of the others are in lowercase at the moment, so I'm going to leave them as lowercase. The other thing we do need to fix, though, is we need to just fix up the mnemonic, which I think we've already copied, haven't we? Yeah, the mnemonic has already been copied. So we can actually write this one directly. Let's just copy it. Mnemonic of MOV. So now if we do this, hopefully, oh no, we can't just copy that because there might be condition codes on it. What we can do is do string copy, just copy 3 characters. That'll do. And then the setting flags, yeah, these ones down here are coming out okay. So if we go back to our comparison here, what should happen is it should say, oh, we haven't written it to a file yet. Let's just do that. Write it to a file. And, oh, I'm just clicking it to make it reload. Thank you. So I want to reload it, and better, we're down to just case differences now. Cool. So that's quite good. That's part of it done. In fact, because that's part of it done, let's just commit that. Check out MSB. Were we already on a branch? Were we already doing this? What do we do? Yeah, that was last Sunday, wasn't it? Yeah, so we just want a new branch in here. I could always just leave it on master. I'll push it straight to master. It's not like it's going to hurt here. We're not actually wanting to branch it off. It's going to be finished this time. So commit. Right, what have we done? Updated output of, oh dear, not getting the words right here. Modern LSR register shifts to older RISC OS format. Isn't used. most familiar form for RISC OS users. So we put things back to how they expect. Right. That's now done. Okay, so we've got one of those things fixed. Which should we have a look at next? So these are all just things about different values that are similar. So yeah, we can probably cope with those being as they are right now. We might put some bits in for these comments, but let's just get through the actual instruction problems first. Table dispatch, don't worry about that one. So these ones, this is really down to how you want to interpret higher than or same and lower. So they mean the same thing. CS and HS, CC and LO mean the same thing. Undefined instruction for set end. It's kind of interesting. Not sure what that means. Whether it is actually a debugger problem. Let's have a look, shall we? So we're over here. Let's have a go. ARM 32 set end instruction encoding. Here we are. I'm not even sure which of these classes of instruction encodings it's going to be. Is it a miscellaneous one? Let's try this. Oh. Just have a quick search and see if set end turns up in this. It doesn't. Let's just try under miscellaneous. Actually, wouldn't it be better if I looked for it based on the actual word that was being output, which I don't know. Okay, just pop over here for a moment. So this is RISC OS Pyromaniac. No, it isn't. Because I jumped straight back again. Right. Less test code slash s slash debugger. It's debugger. There we go. Okay, so we're looking for after movly. So it's a mov nv move never instruction. So we can be sure then that this is actually set, all bits set at the moment. Since in move never, all bits are set. I believe that's the case. Pretty sure it is. So let's go down here. These are all Right, so let's go back. So I need to find, so if we look in here, decode instructions, there's one with a 111, that's an immediate, I don't know. Find all cases of 111. 87 of them, okay, that's probably not going to help me. Maybe I just need to, I know what I'll do. I know what I shall do. Let's exit this. And we'll just go and disassemble, print out all the things it's doing. So, there's config. SWI traps equals debugger disassemble. That's not right. It should be trace.swi traps. trace.output, put it out to standard out. So all of our tracing output will come to standard out, and then we can pipe it all through less. That's not the right, I'm running it in the wrong blooming place here. That's completely the wrong command. I still want these bits off the end of it, but that's running my presentation tool. It's not going to work at all. Copy. Over here. Oh, I don't think that worked. Oh dear. Let's see how we get on. Oh gosh, what have I just done? My lagginess is being annoying. Alright, let's just kill that window. What? No, I didn't mean move it down there. I said kill it. Terminate. Okay, fine. Not having a lot of luck with this today. Right. I'll just drag that down. Not resize, not do that. Resize, please. That's better. Right. Test command. Not writing to there. Config. Trace equals trace.swi traps equals debugger disassemble. Config trace.output equals stood out, and then pipe it through less. Now find set end. There's the set end instruction. And if we go back to that's the SWI exit there. This is the SWI entry. That was the encoding it tried using. Okay. So we can now try and work that one out. I didn't do too well, but that's fine. Okay, so if we go into and basic debugger underscore disassemble that word 8,000 no pointing. It may be that I've used debugger disassemble wrongly. Embarrassing. I've forgotten how it works. Oops. R2 is the length of the line, not the address of the buffer. So we read the wrong thing. Let's try that again. Set end 0. Okay. So the number is F1A. Oh, decoding it like this is going to be painful, isn't it? It's definitely 111 though. Not 111. Not 11. Not 11. That's 11 SMC. We wouldn't be wanting an SMC instruction. These registered under miscellaneous. Let's just go to miscellaneous, shall we? And just see if it's going to list them. No. That didn't help. Branch, Set end isn't defined there. All right, let's jump back to our Google search and then that's kind of interesting in its own way as well. Ooh. That's ARMv8 instruction. That might actually be an interesting thing to look at later. I may come back to that one. I'll leave that open. Okay, so ARM32 set end instruction encoding. That was what we're looking for, wasn't it? That was where I was. See if this gives me anything better. Ah, this is more what I was looking for. SM, SH, set pan, privilege access never. Set engineness, there we go. I've lost it now, there it is. Set engineness. Right, there's our encoding. Those. And the engineness is just there. What do the brackets mean? Does that mean they don't matter? Or does that mean that they're not important? Or I'm not sure. You know what I'm going to do? I'm going to pull up another copy of ARM32 and go back here, because that was actually quite an interesting encoding. So what we do know is that bit 16 is set and that bit 24 is set, and some of the others as well. So unconditional instructions up here. So presumably those three is 0xx. We know that it this is looking better, isn't it? This is what I should have looked at. So op0 is in. So what did I say? I said we've got 24 bit 24 set. So if we just go over here, we've got top 4 bits. Then it's going to be 1, 2, 3, 4. Oops, 1, 2, 3, 4. Then 0, 0, 0, 1. So that should be. Oops, let's do this in hex. Sorry. F1, and then the next bit is A. A is 8 plus 2, and then 0. Ooh, no, that's wrong. That's 8 plus 2, not 8 plus 1. There we go, F1, A0. So that means we've got bit 28 set. 28 set, op is 3 bits, that's this one here, and 24, hang on, what was on 24? No, that's wrong. That's wrong, isn't it? Sorry, I've got confused. 28 is a low bit. 0, 0. 24 is the 1, 2, 3, 4. That's right. And we have set, clear, clear, clear. So up 0 is clear, clear, set. Are these opcodes going downwards or going upwards? I can't tell from this. I'm presuming they must go downwards then. If they go downwards, then that's set 0, 0. And that comes into miscellaneous. Let's go to miscellaneous. If I just search for set end in here. Ah, set end, there we go. Okay. Took me all that blooming time to try and find it. Ah, dear me. I feel very stupid. iMod? Instruction modifier, I'm assuming. M, mode. And these zeros. Not sure. Anyway. Yeah. M doesn't matter. Mode is those. But it's suggesting that all these should be 0. Does it explain things, do you think, in the... oh, I didn't expect it to do that. Oh, where have we gone now? Well, that's frustrating. Miscellaneous. No, I searched, didn't I? That's why. I searched for set end. There we are. Yeah, so at this point, change process state it's classed as. That makes sense, yeah. And mode has whatever bits we don't really care about those there. On the end part. Okay, so those are obviously aligned with the top bits. Fine, I understand now. Still not sure what that notation means. So let's just go here and see if it's described what the notation means. No. No, I feel rather stupid. Can't quite understand what they mean. All right, well, let's go back over here. And we'll just have a see what the actual encoding is and see whether we actually have got something sensible. So, 4 ones, we have that. 3 zeros and then a 1. And then we've got 1, 0, 1 here. So that is not match in this one, and that would presumably make it an undefined instruction, because it doesn't match the criteria that's defined here. So let me just jump to the top. Change process state, go there. Right, there we are. I'm in the right place now. So that's where the decoding's gone wrong. It's still trying to apply this encoding to it. So let us have a look back at the source code. We might be able to see what's going on with it. DOM here. Oh, this is probably going to be really complicated. It's probably in the table, isn't it? It's probably part of the table structures. That's probably going to make it very difficult for me to work out how to do it. DOM gen, DOM table, Table 2, table instructions. Oh, that's just a list of the instructions. Yeah, that just has the instructions labeled in there. Ooh, this is interesting though, because it's kind of got a, a definition that looks very similar to what's actually in there. In the actual set end definition of the instructions here. Although it is unclear which of these bits are actually talking about. I just go into set end. Come on, into the end. Yeah. I don't know what any of these actually mean, which fields they refer to. Because if I look at this, I've got 101101111. Could be anything. Oh, thumbs. Oh, don't want of those. No, we don't want the thumb version. Ah, maybe that table only deals with thumb instructions, and this one. Ah, that looks a bit better. But it does look like there's a 0, 0, 0 here, so it shouldn't have matched. That makes things a little bit more tricky, doesn't it? Because if it shouldn't have matched, then it makes you worry that why it did. Assuming, of course, that this is actually mapping the entire sets of registers. Okay, let's just go up here. Commented out instructions include a number representing the type that implements this particular instruction. Edge case instructions. Okay. No, they're slightly different variants of the same instruction. So some of these tables are actually much longer than others. That's where set end was. Where's set end? I've lost it. See, it doesn't actually have a condition there. It has cond, it doesn't have that. It uses something else. I'm assuming that cond is a marker of some form. Yeah, cond is a marker that says that there are 4 bits. Interesting. Kind of cute, really, the way that it's working. And then presumably it steps through each of these to generate you a decoding table. So ARMv7 is the name of this. What's this table 3 do then? Oh, that's all of the FP instructions. Oh, lovely. In theory, I could probably extend this to add the floating point instructions. It'd probably be a bit complicated, but I think I could probably do it. I might do that offline actually, because it's going to be way involved. Let's search for ARMv7 in here. This looks like they're using a bunch of matchings to try and determine what it actually means out of it, which is quite cute. The set instruction takes 0 or 1 as an operand. Engine specifier, E. Oh, okay. Didn't know that they existed. Instructions. Just check there's no other special cases for set end in here. No, just the thumb variant of it. License file. Various instruction types. I mean, this is all very interesting, but I'm not sure this is helping me much. I mean, these tables are quite clever, I must admit, but just to see if we've got any other set end in here. No, set end isn't given any special case. Our table here. So those are those tables. DOM internal, or is it ARM set? Ah, it's this thing here that actually does them. They've got a bunch of types on them. Plus format strings. Ah, right. So they once they've decoded an instruction, they've decoded the parameters into a set of format strings, so you can know what you need to output. That's actually quite sensible. Labels. Set end in here will be just the E, just the number, and that's all it has for that. I don't know where the bit matching happens, because there doesn't look like there's actually any. It's got labeling, shifts, instructions. There's no like table of bits that are being processed in here. Those bits are in the Python table, but I don't see them in this file. And that's the thumb table, thumb decoder. Thumb 2 decoder. Okay. So I'm a little confused. It is also possible that in some of my manipulation of things, I screwed up and missed a conditional somewhere. Oh, this looks ugly, doesn't it? Ooh. So what does Darmstra disassembler? So this is the one that's actually given a word. The thumb instructions, okay. Please significant. Check whether this is thumb or thumb 2. Okay. Is it a thumb 2 instruction? Bounce over to that. Otherwise, it's an ARM v7 disassembly. So that one. Presumably, that goes into here. it does. Okay, if it's an unconditional instruction, we'll go over here. Ah, there we go. This is how it's doing it. Right. If shifted left 25, let's go over to 25 and 111 is 0, then it just says that's a set end instruction. It's not paying attention to bit 24, which is required, or 16, which is required. So it should have recognized this as an invalid instruction. So let's just quickly put some bits in here. Check. Or from actually would be better, wouldn't it? Because we've actually located the instructions from there. If word ampersand so 24, 23, 22, 21, 20. Actually, if we just shift it right, do the same style as they've done, shifted right 20, ampersand B 1 0 0 no, and 1 1. 1 2 3 5 bits. One. And the other bits that I'm just going to ignore the bracketed ones and the assumption that that's possibly undefined for now. But we need to check whether 16 is set. I've got too many brackets there, and I didn't need to put a bracket there. That's right, yeah. Only if those are set is it that. Else not set end. Okay, quit this, rebuild, and then do the disassembly again. We don't need the heavy disassembly, we'll just do the one that we can see on the screen. This is probably not very exciting, I'm afraid, sorry. Where was the set end? I've forgotten where it was. It was somewhere in the list. Oh, it's on the condition checks, wasn't it? And it still comes up as a set end. That's annoying, isn't it? That's annoying. Did I get my precedence wrong here? Probably not, but let's just put brackets around it anyway, just to be completely clear. Okay. Not make, no. Make module. Actually, we want to make the lib, don't we? That's why. Make lib. Not make. RISC OS ammo. Mov CC still comes up as set end. Well, that's kind of frustrating. Oh, hang on. That's also incorrect. That should return -1 to say it's invalid. So that doesn't fix it because it's clearly getting into this bit of the code here. Let's do a printf word is oh no, you don't write it like that. That's not C code. Export. I bet I didn't export it. Undefined instruction, and it's printing out my message. So we can get rid of that message now, and we can make this rebuild. Oh, hang on, no, that's the wrong one. Oh, stop that. Oops. Right, there we go. What I wanted to do was build the library first and export it, and then we can build the module. Undefined instruction. Okay, we're getting somewhere. Yeah, there we go. Fix for set end being recognized when by the wrong bits. Checks for set end were not sufficient. This meant that the instruction was not decoded properly. The 0 bits that we are interested in are now checked. Okay, there's 1 bit in there as well, but that's fine. Okay, so that's the set end bit done. Let's do find the one that writes to there. Let's go and do the look at what's different between the two. Oh, sorry, that took a really long time to get to that point, didn't it? Gosh. Right. Here we are. Yes, reload it, please. Okay, we've now got undefined instruction, which is what we wanted. Just the cases and the numbers being shown. Right, on these ones, we've got the P being missed off, which is probably significant in ARM code. So I'd kind of like to include it. If we just have a look at the instructions. compare immediate is actually one of the forms we need. As I kind of expected, there's no actual specification for the P bit because it is legacy now. Don't want to throw encoding anyway. So it's probably one of these bits here, or possibly one of these zeros. Not sure which. So what I'm going to do is home. Oh, I haven't ever looked at it. Oh, where is it actually? Is it on Luna? Charles. User works. Excellent. That's very helpful, but I'd kind of like to actually find the right page. That's the wrong location. This is the location I want. There. Whee! Okay. This is a much older architecture reference manual. And all being well, we're only going up to V5 here. We'll have the notation for the compare instruction, which would be under alphabetical list of instructions. Let's try that one. Right, let's just spin down here. Oop, I think I've gone past it. Oh. CMP. Ah. It looks like it's not defined here. Find TEQP. No. Version D. Let's have a see if we've got one in there. If not, then I'll just work it out and we'll see what we can do. No, CMP. Quite a few of those. Ooh, lots of those. No, that doesn't link me there. It's the general instruction encoding there. I think this is also a bit too late. Thanks, Alan. He said that done well. I'm pretty impressed you've managed to track down the issue and have a fix. I think the CMP is going to cause me a bit more problem. A25, here we go. Yeah, this doesn't look any different. So I need to have a look back at something a little bit older. Do I have any other documentation here? On quick reference, ATPCS, the cookbook, unsorted for things, unsorted. Okay. Yeah, we got a lot of old ones here. I wonder if there's ARM 7500 documentation. Oh, that's because of course 7500's got a whole bunch of things in it. 710. Okay. Find TechP. TechP. Here we go. The TechP formed on earlier processes shall not be used in these 32-bit modes. Good. So it shouldn't be used, but it's important that we know what it is, because otherwise something that's in 26-bit is going to come out undescribed properly. So what we can do is we can look for the tech instruction. That's the decoding there for that. Pop down to there. Oh, is that all we're getting? Surely that's not all you're going to give us, is it? It's probably just going to say refer to the earlier manuals. For the, yeah, because I've just looped. Okay. Maybe this isn't early enough. Let's go a bit earlier. ARM 610 documentation. Find B. Still described as shall not be used. Nothing else in there. That's the tech, your but not writing results. That's the same message again. Yeah. Yeah, we know we should be using MOS and MSR. Okay. So, let's try this a different way, because there's always other ways. // not that one there, but that's a good starting point. Sources, programmer, debugger. There we are. This is the debugger source code. Let's jump into here, and this is probably going to be a bit of a pain, isn't it? Because if we try looking for the letter for TEQ, we're going to find it turns up quite a bit. Let's search for the word comparison. Okay. Set is required for comparisons. Bit. If you use 15, it signals P flag on compares. N, if not used, there's RN is the right. Okay. What? I'm confused now. I'm even more confused. Right. That's where MLA and MUL are processed. This is where probably the RISC OS 5 one's been way expanded over what I've got here, which is a good thing. It's just a bit of a frustration when I've got an older version. Right, here we are. If it's a tech just branches lower to 4 to 10. I think that means we should be going to 10. this point. Oh no. Right. If R5, which is RD, is PC, then it's something P. Is that always implied? Is that always the case? Is it always if you use R5 PC as the destination, it's always got P set? I guess so. Branch of equal to there. Hang on, where is R5? This is at offset 16. So let's go back to the instruction set definition here for the data processing instructions. For the comparison, I want comparisons. Comparison have 2 R's. Compare then. Huh. Data processing and miscellaneous instructions. There we go. It's actually explicit. So let's just go to that one and we'll see the explicit encoding. Oh, so R5 is R4 shifted left 16. R4 is the word that we're interested in. Fair enough. It's not. Oh, and then R5 is being done here. Ah, right, okay. I see. R5 is R4 shifted right 12. 12. These bits here are zeros, but they could be 15. If they're set to 15, it's a tech P. Okay then. And if they're not 0, it's an undefined instruction, according to this check here. Right, so having found it in the debugger source and knowing how we need to represent it, let's go back to the ARM code here, and we're going back to wherever the unconditional code was. ARM decode, here we go. Oh no, not the unconditional, wherever that's called from. Here we are. So it's conditional code, so this function. Copy paste to there. They detect the mul instruction first, similar to how we do in our debugger. And then we have the fun things here. What we got here? Is that still part of the mul? That's still part of mul decoding. Synchronized primitives, stores, LDR pops, saturation instructions, packing, unpacking. Okay. And then we go down to the main code. Shifts, branch instructions, move immediate, comparison op. and comparison immediate. So if W shifted right 12 and the 111 is not equal to 0, this is a special case. RD should be 0. However, on the earlier arms, this indicated the P bit on text P, which I've just realized I've got no way to represent here because the table doesn't drive it. I've got no way to represent it, at least coming out of this particular chunk of code. Well, that's kind of frustrating. You know what? You know what? We won't edit it in here. We'll do a very simple check here. Just need to make that in brackets actually. Should be 0. On earlier arms, a value of 15. So what we'll do is we'll just check for B. Right, there we go. Undefined instruction. So some of this is going to be a little bit flaky. It's not a big deal. It can be fixed up later in the future if people wanted to have a play with some of this disassembler. I mean, there's always a possibility that somebody could write their own disassembler and just dump that in place of the DOM disassembler that I've got, because why wouldn't you? It's relatively easy to do now. But since we've now recognized that is the case, we can go into Rodis here. Oh, not the header file, sorry. Into Rodis up here and find the comparison instructions. Oh, this is interesting. Oh, this is interesting. No, I think that's right. I think that's actually correct code. Seemed a bit odd there. Right, let's do this here. Else if, in fact, this is going to look very similar to the checks up here. If it's C M P or N, and if it is TS T or T E not Q, that's a P there, there, too many brackets, there we go. CMP and can have a P on them. If we have 15 in bits 12 to 15. I think we've got the word, haven't we? Yeah, it's called word. That's good. Let's get this finished and then we can have a break. That's an hour and a half. That's a long time for me just to get to the point where I've done a couple of things. I'm quite disappointed. But then I'm always disappointed, so you're 32T RD equals word shifted left 12 underscore B, isn't it? 111, like that. If RD 15 stroke cat mnemonic. I think that's right. Let's try it out and see what happens. Not doing that, let's write it to here. Oh, that isn't actually valid syntax. They've defined the value of those bits. I did wonder how that was managing to work. 15. Right, CMP. No. I don't think it... Oh, hang on. No, those are correct. It's the special ones. Special ones. Oh. Oh, that's interesting. That tech hasn't got one on. Oh, that's because I put the wrong letter there. That should be a Q, not a P. Right, rebuild that and just test it. There we go, all those three have now got them on there. So if we write that out to the file, as we have done before, and then we go and look at the diffs up here. Yeah, reloading it. Reload it again, please. You haven't actually loaded it. Thank you. There we go. Right. Scroll down to where we've got the CMP comparisons in here. Oh, that one's different. Oh, because that's got the annotation on it. That's fine. All right, so we've now got the nasty bits with the status register, MRS and MSRs. So let us just get this committed and then we can take a break and have a bit of a rest. Oh. That was a lot of work just to get that on there. Oh, I wanted to make the library as well, didn't I? Let's just do the library. Not make library, sorry. That. There we go, rebuild it. Thank you. And then we can just build the code. Let's check that it actually does work with the library built that way. Embarrassing if I'd broken that as well. Yep. Still working. Good. Ensure that TechP and friends are identified in assembly. The B bit isn't usually used. Isn't designed for modern ARM systems. Really useful to highlight, highlight it. We now include the P on the instruction. There we go. Done. let's push that. I didn't push the last two, I'm sorry. Right, there we go, they're pushed. So, we've managed to do, what have we managed to do? Come on, last three logs. So we've done TechP and those additional comparisons. We've got the set end being recognised with the wrong bits, which is kind of useful. And the register shifts, the mnemonic instruction is now coming out correctly. That's been a lot of work. I'm going to have a look at the MRS, MSR, because those are vital. And I don't think I'm going to get to DebuggerPlus today. I'm definitely not going to get to it, I think. So we're going to have a look at those. And I suspect it's probably the same sort of thing, that the instructions in the... brain's failing me. In the original DARM code are not being decoded properly. So we can have a look at that and see what we can get out. All right, let's have a break for 10 minutes or so, and then we'll see how we can get on. All right, see you in a little bit. Hello peoples. Oh, sorry, that was a little longer than normal. Oh. And I don't need my headphones. Right. Oh, we have an Andrew. And we have a Paolo as well. It's all right. Glad to see you both here. So, what have we been doing so far? It's been very, very tiring. It's taken a very long time. We've got 3 things done this first part of the session. So we got the MOV instructions that come out as LSLs. So up here. So this is the differences between how Pyromaniac produces it and how we produce it here. These used to come out as LSL, LOL, LSL, LSR, ASR and ROR instructions in the mnemonics, and they're now fixed to come out this way. And the second thing we did was, I've forgotten, give me a second, it's on here. Oh yes, one of these instructions down here that was a undefined instruction. So this one here, mov never something, was coming out as a set end, which isn't the instruction, it's an undefined instruction. And that was because the base disassembler was actually disassembling it wrongly. It was disassembling it with, it wasn't doing some checks on it, so that was wrong, and I've now fixed that in the base code. And down here, a bit further down, somewhere, here we are. These P instructions here, come in, tick, and TQP and friends. Those weren't being decoded properly because it's not a valid instruction sequence a bit sequence anymore. And whilst it's not a valid instruction pattern anymore, opcode, bit pattern, it is very useful to recognize that that is the instruction that was intended originally, because those may still be hanging about from 26-bit code. So I have restored that into there. The next bit to have a look at is this status register stuff. So all of these bits that come out as MRS and MSRs, they're just not working. I'm not sure why. So that's going to be the next bit. I'm going to give that a go, and then if I get that fixed, I think we might call it a day there. I had intended to do the brain's failing me today. It's obviously very slow. I had intended to do the really failing me DebuggerPlus SWIs, but I haven't got around to any of that, and I think it's going to be next time because this just took a long time. So, with that in mind, let us start having a look at what these instructions are. So, when we were looking at them earlier, we were looking at the way that the code is built up. The instructions are decoded inside the original code, the original DOM disassembler. And they do have a bunch of tables involved, but those tables appear to be just the patterns that are involved in them. So instead of using those tables, they've actually got some explicit decoders. So let's just have a look in here and see if we can find MSR. So there we go, there's the MSR instruction. But as far as we can tell, MSR is never decoded in here. We've got smlab and smlab. I'm not sure that's how you're meant to pronounce them, but that's what they are. And some wait for interrupts and some others. Which probably means that these types of instructions are being special cased somewhere. So let's have a see if we can find them. So this is signed, multiply, and add. That is that instruction. It's also using PC there, which is rather crazy. I wonder if that's because the PC, we should probably be recognizing that there's a PC involved in this, and that's probably the identifier for an MSR. That's probably where they've gone wrong. So let's go back over here, not over here, over here, and try and find the MLA instructions. Interesting. So those ones are there. Those are definitely some of the instructions. Here we go. Right, okay. So they're recognizing that they're multiply instructions by the fact that they've got 1001 in whichever bits these are. Ooh, that's nasty. We have to take two parts of the instruction, an encode instruction, namely bits 25 to 27, which should be 0, and 4 to 7, of which 4 and 7 must be set. Okay, probably there's also some other bits that must be clear. So we'll go over to the instruction set and we'll find the mul instructions. Now I've gone past it because I've forgotten how the alphabet's ordered. MSR, mul. So between these two, that's what we're looking at here. Let's just have a quick look. So 1001 is in 4 to 7, and then up here they're checking that at bit 25 upwards, whoop, that's jumping around all over the place, but 25 upwards, those 3 bits are clear. That's interesting. But actually for the mul, all of these have got to be clear. Let's just have a look at the S variant of it. Come on, where's the S variant? S, oh, let's say S, smaller, but that's the ones. That's got bit 24 set, but 20, 21, 22, 23 all clear. And some lads, lots of fun ones here, aren't there? Oh, these are ugly. These are really ugly instruction names. So they've got some bits set there. Okay. $24 for that one. 24, 21. At the very least, I think 22 needs to be clear. I'm not sure. Yeah, it's just being a little overzealous on what it's recognizing. Let's just have a look at the MSR again. MSR has 20, 21 set. Okay. And MSR immediate. Banked register. 20, 21, 23. So the code in here is checking bit 22, bit 24. 23 and 21 there. Okay, so let's just filter out 23. I don't know, what was 23 being checked for? 24 is being checked there. 23 is being checked there. This is the not sure what instruction that is. Stack 1. I'm not sure what stack 1 means. It's obviously a particular type of instruction there. Not sure. But anyway, 2021 must be careful not to misidentify MSR and MRS. Actually, what is MRS? Because presumably the reversed version has one of these bits clear. Ah, all of these are 1s as well. So 21 indicates the direction. So if it's 0, then it's MRS, and if it's 1, it's MSR. So 20, 21, 23. If those are 0, no, 20, hang on, 20, 21 is the variable one. R is, what's R? Oh, it's SPSR. Ah, SPSR rather than CPSR, that makes sense, yeah. Yeah, and that's the registers to pull out of. There's a whole bunch of things there that I wasn't sure we could do. Oh, that would have been useful to know earlier. Didn't know I could do that. Some later today, so I'll have to have a look at that. But anyway, right now, what do we want to do? We want to go and recognize this by the encoding 20, 21, 24, it looks like. No, 20, 23, 24, sorry. 20, 23, 24. Constituent. Yeah, can I just merge that into this one? That would probably be a lot easier, wouldn't it? Although some of these actually want to check. Const units 32 t mask 2 equals mask MSR. B 11 shifted left 23 or B 120. And W and some mask is not equal mask MSR, not equal to B10, just left 23, or just that, isn't it? Because the other one 20 is clear. Yeah, that's kind kind of fruity. I'm not sure that's completely correct. I'm not sure that's going to completely catch all of the instruction types. But this is one of the useful things about having tests for it, because we can incorporate some of these instructions into our tests. Well, in theory we can. Make the library. Done it wrong again. RISC OS ammo. Oh, brain. And then like that one. Right through S. I'm sure other people probably have a better idea of some of these later instructions than I do, because the signed multiply things like, whoa, that's all very fun. And I'm a bit old and set in my ways. Actually, this is at the end of the file, isn't it? Oh, maybe it's not at the end of the file. Oh dear. No, we're still getting these wrong. They're still recognized as status registers. I'm sure they shouldn't have been. So I keep flicking back to this description, which of course you can't see that I'm flicking back to. I'm trying to check, so 20 should be clear. 23, 24 should be set to 10. And we're already checking those are clear, and we're checking that in shifted left 4. Oh, hang on. 1001. This isn't the right code, because this bit won't have been triggered. I'm looking in the wrong place. So, if that's rubbish, surely not. Dave says, is it done yet? No, I'm still screwing it up. It's okay. I think I've got, because I'm getting, just so you know, Dave, I've got all these things here that are meant to be MSRs and it's decoding them wrongly. So I'm trying to work out where in the original code of DARM we've got that happening. Oh, yes, I see what's going on. So this is a check here for these parts of it. One shifted left, so 1001 shifted left 4. But then we come down to this bit, which handles these instructions. They look a bit over wide to me, but okay. This is saturated operations. No, not those. It might be something related to this. Come on, keep going, keep going. Scroll down a bit faster. Oh, I don't know then. SMLA. SMLA. Not that one. There's SMLA. So that's when it's identified it as SMLA. Which it did how? TARMSM. So it's already recognized it as an SM instruction, signed multiply instruction. Where does it get this recognition from? Instra type. Instra type is here. and that's W shifted left 20. Which is this lot here. And I'm assuming that ARM instra types are in here. Here we go. Oh, great. Yeah, that's a little bit difficult for me to parse, I'm afraid. Let's see the code generator. See, that's got a nice little pattern in it as well, but we're not recognizing it based on those, which is frustrating. Where's the instra type come from? Hang on, what? Is it called instra type? ARM v7 instra types. So it must be in one of these files. Ah, there. First handle all the English. These are all very, very, very confusing to me. Okay, let's go back down to there. Instruction names. Darm tubble. Oh, this one here. Okay. Oh, the stack instructions. Oh, they're not stacking. They're just writing to memory. It's clearly got a little bit of a difference of terminology there. Just look for the MSRs then. What are they classed as? Ooh. They're classed as branch and miscellaneous. Okay. MSR is in branch and miscellaneous, that's correct. But it's already been misidentified and not gone into this branch and miscellaneous column. I think that's why it's going wrong, because it's then being misrecognized elsewhere. So, BR and CH misc. That's got to come. Oh, instruction lookup. So there is a special lookup for that. So somewhere where it's assigned it to that is where it's gone wrong. This is the instruction type table. It's a like 256 byte entry table that actually maps bits 20. So what would that be? 1, 2, 3. 1, 2, 3 times 1, 2, 3, 4, 5. 3 times 5 is 45. So that'll be 46. 47, 48, 49. 49 is 48 plus 1. I must have got that wrong then. I have got it wrong because that's not number 1, that's number 0. So that's 48, that will be. And 48 is... What's 48? 16 plus 32. Which I don't think is correct. Because this is going into this thing here. So 16... I think I'm sure it's 20. No, 1, 2, 4, 8, 16, 32. That's not correct. If those two bits are set, this is not an MSR. So maybe I've got it wrong. 1, 2, 3 times 1, 2, 3, 4, 5, which is 45. 46, 47, 48, 49, and then 0 reference makes it 48, so it is quite right. Is there any others that are coming out as BRMCH MISC? No, only that one. So maybe I'm not thinking of the wrong shift, maybe. Instra type equals look up the instruction type based on the word shifted left 20. I'm very confused. Because if I'm reading this right, it should be 2, 4, 6, 8. It should be at offset 10 and 14. It should be set on there. If I was to scroll down until I get to the French MISC, so this is a separate lookup table that's based on shifted left 4, which is 000 for the MSR. Very, very confused. How is that generated? Is punch MISC in there? No. Is it in here? No. Is it in here? No. Is it in here? Yes. Type lookup. Print lookup table for French MISC. Ooh, there's a special check. Ah, interesting. Bits 1 through 9 should be... I don't know what those bits are. Not sure what these 3 parameters are going to be in this function. Oh, blummineck. This is all very clever, but I'm not sure I really understand it. Yeah, I'm sorry, this is not very exciting. I'm just trying to get my head around a lot of this stuff and not getting very far. So this ARM7 stuff here is actually like building a tuple of the parameters that are in there. And this then generates our instr types table, which is fun. But I don't know how it's actually called. General purpose instruction. So there's the sign multiply instructions. Oh, okay. So Y has clearly got the instruction name in it. Hang on, is this built from the big table that we saw? That big table that we saw that had all of the values in it. Hang on. MSR, please. Where is it? It was in one of these blooming files. Are these evaluation order? That is a possibility that they've misordered things and one of them's coming up before the others, which it needs to have. 0. Maybe that's not the right order. So if they are, arithmetic immediate, branch MISC, back to that table. So this doesn't tell us that they're particular instructions, but the SM might come out first. And it might have identified it first as a signed multiply. Oops, I think I've left an extra left. Oh yeah, I deleted some things. Whoops, that was careless of me. It does also imply that some of these branch with BX might not be working and breakpoint might not be working. But we know that breakpoint is working because that came out all right. Three zeros. 3 zeros, 1, 0, 0, 1, 0. Except that R is the MRS rather than MSR. Ooh. Hang on, I've just noticed something. This is parameters 1 through 9 here. And if I go back over here and I ignore this first word, then 1 through 9 will be this one. Oh, what was R? R was the SPSR. So actually it's possible we may not even be recognizing SPSR at all in this, which is a little frustrating. Maybe, I'm not sure. But if they are being executed in order, then you'd kind of expect that the ones that the SMLA and others were in would come up first, and they're not. Actually, it can't be executed in order because invalid is first. Oh, except that always returns false to say this isn't the thing. Ooh, ooh, ooh. I don't understand. I'm going to what am I going to do? Because we know that the SMLA is coming out wrong. Hang on. I can use my head here. I can use my brain. A little bit. Just a little bit. If it is the value shifted right by 20, whatever it was, by 20, then this value here will be 1, 2, I think I said 10 or 14, didn't I? So those will all come across as being arithmetic shift. If they are arithmetic shift, then surely the ones that are in the operations that are in arithmetic shift would be the ones that it would be coming up with. But we know that it isn't because it's those. What about the WFI? Where's WFI? Oplus instruction lookup. So that's clearly being misidentified there. Because that's not that instruction at all. And if I have a look at WFI here, come on, where's WFI? Oh, really? Let's get rid of this message. Hang on, what? Find. Come on. WFI. Oh, there we go. Okay. Wait for interrupt. That's a different pattern completely. that's a different pattern completely. I'll go back to where I was. Oops, no, not that one. Go back that way. 0, 0, 0, 1, 0, something 1, 0. 0, 0, 1. Yeah, that's completely different. And MRS, also completely different. None of which look like that. And that yield doesn't look right in the slightest there. In fact, none of those look right. I think they probably ought not to have a set of parameters on them. Yes, because that LBB is coming from here, isn't it? That's what's gone on there. So I've got myself a bit confused, or it's got itself a bit confused, one of the two. Right. Two sets of problems there. Let's... Let's just see if we've got an easy way of spotting how we could have generated that wrong set of parameters. Because at least that's my code and I, in theory, could understand it. So args comes out of the length of the mnemonic plus 1 . Oh, what if it was just terminated? I imagine that's what's wrong. If args bracket -1 is a terminator, args -1, just go back one and we don't have any arguments at all. Let's just, if I can fix that bit, then that's one step down, one thing fixed. Dave suggests this is a 2-pineapple problem, and Terry says we need a Del Monte man. Fortunately, he's always saying yes, so he can definitely come and help. There we go, that's all right. I feel better at that. We've now got some things that are coming out as just the plain parameters. Fix for operand-less instructions. Some of the instructions take no and would be given the previous. Instructions. Over fun. Okay, so I still don't understand why MSR is not being recognized. Let's just stick some debug in here. Instr type equals word equals offset equals not use user x. Yeah. Something like this. Okay. So that's d to instra underscore type and w shifted left 20 and there we go, and I've missed a bracket. Okay. Make the library. Make the module. This is taking a while. What's going on? I guess there was a lot of output because every single instruction is outputting even more stuff. Okay. The bit I was interested in was the bits around the WFI. So I want the bits up here. Hex 10 and hex 14. Yeah, that's what I thought. And those are coming out as instruction type number 20. And then those are coming out as type 16, because that's the 2-bit, that's the R bit toggling. And 12, which is 10, that's the R bit for toggling, yeah. So basically the filtering for these instructions is just wrong. That's 32. Where am I getting 32 out of that? That's an extra 20, that's bit 25 set. It's gone too far. MSR, MRS, did I pick up a set? MRS, yeah. MSR register. Yeah, 25 set for some of them. All of bits 2 to 15 need to be set. And the banked register version, I'm not using the banked register version, let's leave that for now. If all those 3 bits are set, and they appear to be for every single, or those 4 bits, sorry, are set, and they appear to be for all of these, except that one. But that's a different form of MRS. And that special register, what's that one doing? Oh, that's the... Yeah, okay. Basically, the MRS and MSR for immediate values and register is the most relevant one. It feels like this should be a special case up here. Okay, nasty hack. If D to, let's work out what our mask is going to be. So actually we know what the mask is going to be because it's going to be all of these 4 put together, isn't it? So it's going to be 3, 6. So if the bottom 4 bits, so if W shifted right by 20 and XF not F, bit 1 can be clear. Yeah, that's right. C and which bits can be set? Bit 1 can be set and bit 2 can be set. So bit 0 is clear and bit 4, bit 3 is, that's 9. Is that right? 6. 9 plus 6 is 15, that's right, yeah. And sorry, I've already forgotten what bit numbers those were. 16 through to 9, no. Is it 16 through to 19? (16 through to 19 are set? I've got the wrong one, haven't I? 12 through to 15. That's MSR. Let's make this explicit, shall we? So everything bar that bit, 1, 2, 4. That 255. No. 15 minus 4 is 11. 11 is B. Equals OXFB and W shift to the left 12 and 15 equals 15. Right. MSR instra type equals I_arm br br. What the heck's it called then? Wunschmisk. T_arm, not I_, that's why. Oh, except I want to actually build the library, don't I? RISC OS ammo. And then build again. There we go. What's the best thing this doesn't work? Well, WFI is still there, and so is that. Bother. Let me put some extra brackets around this just to be really clear of the precedence. I always screw up precedence, so I always like to be really, really clear what I'm doing. Oh, that's garbage, that's why. I actually want to set it to 1, 2. There. That's what it should have been. Make the library. Run the program. Good. That didn't work either. Really? OX FB. 251. That's 255 minus 4. That's what I want. That's what I want. And shifted right 12. 1. I am kind of assuming that I'm putting MSR into the right group here, because if I'm not, then I'm being really stupid. MSR. It should be going to the branch MISC one. Oh, but we haven't identified the instruction. Oh, but then the instruction would be identified here. Oh. That's awkward. So it should go into that. No, go back to where it was. Recognize MSR. Let's build the library. Build the module. Am I being just stupid here? Am I misunderstanding something fundamental? It's recognizing. Oh, but it's not recognizing it for the first set. What? What are the first set of instructions? Oh, they're MOSs. Okay. Okay. So that's good. Yes, I think we're doing better. This is an improvement. This is an improvement. Oops. We've got something happening correctly here. And it looks like, if I go back to these, the two MSRs are exactly, that was SPSR and APSR, fair enough. But these ones that are failing here, the first set of them are all register based, and then the next ones are the immediate based ones. So the register based ones are working, the immediate ones are not. Or I'm recognizing them now. So that's something. So, and since I'm looking here at the register based signature, that's okay. Let's go to the immediate based signature. Ah, that's got this bit set, bit 25, which means that I would need to have an extra one set here. So we go back to this, means I need to check that that was clear bit 2 in that nibble. D equals 1, 2. Okay. I think younger me would have done this far more quickly. We don't have WFI in there now, which is good. SM, U, SM. What's these called? They're called status register things. So now it thinks that some of them are branch extended. I think it's branch extended. I don't know what that's meant to be. And others it's not getting. That's a step in the right direction. Let's go down to where the MSR is. And we're saying that we're using the branch MISC instruction lookup code here, which probably is just wrong, I'm guessing. W shifted left 4. Hang on, this is the register one here. and it's 0, 0, 0, 0. In the branch MISC instruction lookup. So branch MISC instruction lookup is in here. Let's have a look. Copy that. Find 0 MSR. So it should have just gone to the MSR there. But it didn't. Which is curious. Unless those bits aren't clear. DIH MISC colon W should write 4 equals. No, not Python. I can do it as hex, it'll be easier for read. W should write 4 and 4, 15. Okay. You know, if I could deal with breakpoints, it would make things a whole lot easier. Did consider doing that. I've just failed to build the library, haven't I? Oh, I did build the library, so that was actually valid. Oh well. So these are called status. 0, 0, 0, 0, 0, which is the IMSR instruction. I'm going to feel very stupid if it came all the way through to this and then there's something else going wrong elsewhere. I failed to build the library again, didn't I? Recognizes IMSR. And then it returns undefined instruction. I wonder. Yeah. So that form is returning it with got a value of 1, but that's a little different. So we actually print out the message undefined instruction here, don't we? So if we get an else from this, str2. So this is where it's decoded okay. You know, I think this may end up having to be a problem for next week because I am not getting it. Maybe with a bit more time. David just said, reminder that young Gerph used to pull out clumps of his hair whilst coding. He is not wrong. So, OK. So what's happened here is OK is set to true, but darmstr2 is saying no. It's saying it doesn't recognize it. So somewhere in here it's going screwy, and I'm not quite sure where. There isn't an IMSR, so there's no special case for this. So ARMv7 format strings, copy, have a look in the table. Is it in this table? There's this thing called a spec reg in there, and this string shouldn't have that present in it. It's not been processed properly. I think that one's also not been processed properly, because this should have converted them to a single letter to say what needs to go into the format string. So I think this is just a decoding problem. It's hit something it doesn't understand. In fact, it's probably hit the less than and gone, I don't understand that, and then returned an error. Let's go back to here. What character is this? Do we recognize it? Is it an SCNMAT2HLIS exclamation mark X BO BMAC, a bunch of things, and then finally hits the default, which will happen with a less than sign, and gives up. So it's because the specification of the registers it's going to go to, the special register, is not present, and it's not got a decoder name for that. Oh dear. All right. For now, let us just call this a day, because there's no way my brain is managing to get through this. If I do have a tinker with it over the week, I'll let you know what I've done. I'm not going to end up doing all the coding on this, I expect, entirely online, but yeah, that's just a bug in the upstream. So yes, I'm frustrated that that's a bug, but I can at least do something with it. So let's see where we've got to today. So today we've had the LSL, LSR, ASR, and the roles, roll and raw, updated. So they're all handled now. We've had the set end instruction is now correctly recognized as a set end for not. And there was something else as well. Can't remember what it was. It was in my list. Not diff, I didn't mean that, I meant log. Oh, and TechP is now recognized as well. So we've done those, that's fine. My test code needs to be expanded with more examples of different types of registers. So we can add different types of instructions, because at the moment we've only got some of the regular ones that will be used by RISC OS. We could probably do with some of the actual SML, SMUL, SMLA, the sign multiply ones, and some of the multiply operations, and some of the others could do with being in there. And that would then mean that we could decode those and check what the behavior is and whether we've broken things. And in the second part of this session, I have completely failed to actually find out how to decode the MSRs and MRSs properly. Which possibly also means that BX and BLX are probably broken, which we could also do with examples of in the test code. So I may update the test code independently, since it will tell me that the Pyromaniac code is working properly, and then we can reuse it here. All of which is, yeah, one of those frustrations. If you use open source things that have been left for quite a few years, they may not be up to date. Of course, part of the point of this is that if somebody finds a different back-end debugger library that they like, disassembler library they like, we could plonk that in place of it. It wouldn't need to be this one. We could do other things. And we could have lots of other implementations as well. But for now, let's just call that a day and yeah, have some rest. Hope you've enjoyed what little progress I've managed to make today. And we'll come back to this next week, or maybe I'll have a tinker over the course of the week. All right. See you all later. Have a good afternoon. Bye.